Okay, Algebra 1, we are in Chapter 8, Section 2, and we are applying exponent properties today involving quotients. Yesterday was all about products. Today is all about quotients. So what operation are we talking about today? Division. Division, okay? So again, you've had previews of this in 7th grade, pre-algebra. Quotient of powers property. Okay, even if you did not know the property that we're working on, you could use what you know about exponents to expand these things and figure out how you can simplify it, right? So in this example number 1, we have 6 to the 11th divided by 6 to the 5th. So what does that look like when you expand it? Matthew?
6 times 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 6
Excuse me,
times
okay.
6.
11 of them. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Over how many of them? 5. So 1, 2, 3, 4, 5. Okay, it's all multiplication between those factors. So what do we know we have when we have 6 over 6? 1. 6 over 6?
Oh no.
1. You're right. Okay, so if 6 over 6 is 1, then 36 over 36 is also 1, and so on. So when we say cancel, what we really are arriving at is 1, right? So we have 1, 1, 1, 1, 1, and we still have some factors in the numerator, right? So how many factors of 6 remain in the numerator?
6.
So we could go 6 to the 6th. So now is when we can develop the rule. How is the exponent 11 and 5 related to this exponent of 6?
Subtraction.
Subtraction. Good. So the rule will be written like this. This could be rewritten as 6 to the 11 minus 5, which equals 6 to the 6th, right? We're just subtracting. When you have the same base power, right? I have a power of 6 over a power of 6, so you subtract. Good. So let's see if we can just use that rule for this one. I bet you can tell me the answer here. Negative 4 to the 9th over negative 4 squared. And so let's say together the answer is negative 4 to the, and you would say the quantity negative 4. If somebody wasn't able to see, they now know I put parentheses when I use that word quantity. The quantity negative 4, that's the whole thing, is now to the 7th because you subtracted the 2 factors that were in the denominator from the numerator. Okay? And let's try it again. We have now a product in the numerator. We have multiplication of 2 powers of 9. 9 to the 4th times 9 to the 3rd over 9 squared. So we have to apply the product of powers in the top. How many factors of 9 do we have in the numerator, Johnny? So we have 9 to the 7th over 9 squared, which gives us what? Good job. So we have 9 to the 5th. Okay, so we had the product of 2 powers, product powers, and the quotient of powers, all in one example. How about this one? We have 1 over y to the 5th times y to the 8th. Can somebody tell me the first step you might take for this? What might a person do, Matthew?
Multiply by reciprocals.
Well, this is just multiplication to begin with, right? So if you are unsure of what to do, what is the denominator of the y to the 8th? 1. And how do you multiply 2 fractions? What's the rule for that? What? Well, actually, you just multiply across the top, and you multiply across the bottom, right? Cross products property is for proportions. So this is just a fraction. You just multiply across the top and across the bottom. Sometimes we reduce though, don't we? Right? So if you didn't reduce yet, you could do this. And so let's say the simplified expression together, the answer is y to the third. Okay? So good. this is all called the quotient of a powers property. Let's do it a little slower here. Quotient of powers. A to the m over a to the n. Can you finish the rule for us, Jack? So, a to the, good, a to the m minus n. And then with a sample, if you want, in your rule box. 9 to the 12th over 9 to the 7th. Sabrina? Good job, she subtracted. Okay, so here we have quotient of powers again. It looks like basically the same, but what happens when you go to subtract those exponents? Hey, end up with a negative. So what would you call this when you simplify it? You're reading. Okay, z to the negative 10. Now, z to the negative 10 is a true statement. However, it's not considered simplified when you have a negative exponent.
Yeah.
So what would we do to this so that it's acceptable form? You're not allowed to keep a negative exponent in your final answer. Ellie? No, but you are on the right track. Matthew? Good job. 1 over z to the 10. Okay, so if you were to expand this, like we did the first question we looked at today, we would have 9 of the z's in the numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9. And in the denominator, we actually have 19. Ooh, I don't have room. 1, 2, 3, 4, 5, 6, 7, 8, 9. And z to the 10 more, right? Just to be brief. Okay, so when we cancel these, what did we say we get when we were doing this?
1.
Multiplicative inverses give you
1.
1. So what's in the numerator when it looks like everything has canceled? 1, not 0, right? 1. So that's why it is equivalent to this. And we know that a negative exponent is all about location, remember? You move the term that has a negative exponent to its inverse location. So this term goes down, and when you move it, you lose the negative on the exponent, right? So what would I do with this? 1 over a to the negative 2. Jenna?
You move it up, so it'll be a to the 2.
Good. That's right. When you move it, you lose the negative, right? But the exponent, the number itself, the absolute value is the same. Okay? Good. Now the next one. Whoops, this is not needed. This was something I did 2 years ago. Okay. Next topic is this one. You can see this is a little different. Rather than the quotient of powers that have the same base, I have the power of a quotient. And these are the only 2 properties we have today. Just 2. We had 3 yesterday. Today's 2. So what does this become? If I have a over b in parentheses, quantity squared. Kate, what does this become?
It's a over b times a over b.
Good. And so can you simplify that?
A squared over b squared.
Good job. That's it. So what does this feel like we're doing? Huh? Did the top term go to the bottom? You mean whatever the exponent? It feels like the exponent is doing what, Cameron?
Distributing.
It feels like it's distributing, right? Do you see that? We're sharing that exponent with every factor in there. One factor happens to be a divisor. The other one's a dividend. Okay? So feels like we're distributing. It's not the distributive property because there's no addition or subtraction there. But it feels that way. And it's exactly the way Kate stated it. It is this. It is this A over B fraction happening twice, which can be simplified. So here we have negative 5 over y. That looks really bad, but it's a negative 5 over y. And the whole quantity is being raised to the third. So can you simplify that? Anderson, do you have it? Hank?
Is it negative 5 third over y?
Okay, but when you say is it negative 5 to the third, are you giving me a quantity in parentheses or out of it? Is a negative being raised to the third in this problem? Is a negative or is it not? It is. So you would have to say the quantity negative 5 is being raised to the third over y to the third. Can you tell me what negative 5, that quantity to the third, equals?
1
Very good. So what is this going to be then when we... Negative. So we could say this, and we should say this. Negative 125 over y to the third. There it is. Evaluate it. Find the whole value. And just as you did yesterday, you may use a calculator. I hope that these cubed ones become really familiar to you. Do you remember what 4 to the third is?
64.
64. Good. How about 2 to the third?
8.
3 to the third?
27.
4 to the third?
64.
5 to the third?
125.
6 to the third?
36 times 6 is 1,000 something.
30?
No, not 1,000.
Do you have it?
216.
There it is. Good job. That was Matthew McCaw right there, just so you know at home. Okay, let's try this one. One more, x squared over the quantity x squared over 4y to the second. And Kyle, tell us what you have.
Okay, so x to the 4th over 4y to the 2nd.
When you say that, are you saying 4y to the second? Or are you saying the quantity 4y second?
Oh,
In other words, is it 4y to the second, or is it 4y to the second like that?
It's
With the parentheses. Okay, so we can simplify this further then. What can you call that down there?
but how come there's no parentheses on the top?
Because he already got x to the fourth. He says 16y, are you done? Y to the second, good job. Okay, there it is. So every term has been affected by this exponent of 2. X squared times x squared is x to the fourth. 4 squared is 16, y squared is y squared. Good. And I think we are done. So let's go ahead and write the rule for this. This is the power of a quotient property. It's kind of funny, but there is a little sample here. The first is the rule. We have all variables. We have a over b, that whole quantity raised to the m. Bless you. Are you going to give me an answer for this? Okay, Hank.
Is it or a to the n over b to the n?
Good job. A to the m over b to the m. Feels like we're distributing the exponent. And so let's simplify. Ellie, can you tell us what c over d all to the sixth equals?
C to the 6th over B to the 6th.
Good job. Okay, I think we have one more tricky one, and then you're on your way. Okay, here it is, a little tricky one. It's just taking many of the properties that you have learned yesterday and today. You actually learned them before yesterday and today, but we're reviewing. We're really working on them. And putting it all together. So can you simplify this entire expression? Where will you start? John?
Does that say 2s in the top, or-
Yes.
Okay.
It says 2s over 3t.
So, 12 s to the
How'd you get 12s?
to the third.
So you're saying that you have 2 to the third, and you think that's 12? 2 times 2 times 2.
Oh,